I was thinking about the other day about the first time I saw the internet. It would have been 1993, late 1993. I was a student, and myself and a group of friends were huddled around a small computer terminal looking at an elementary browser. It was called Mosaic. It's been long gone now. And on the screen, there was a newspaper, a really crude, basic newspaper. And we were able to click with the mouse on the links between the stories and go from story to story. And back then, the world was just starting to embrace email. And the World Wide Web, as we called it, was really nothing more than a group of universities that were linking their mainframe systems together. And the group of us sat there afterwards and we said, where's this technology going to go? We thought maybe we'll be able to do our banking online. And as students, we hated going to the supermarket. So we speculated whether we could possibly do our grocery shopping on the computer screen and avoid having to go and walk down the aisles every week. And that was 20 years ago. And before the dot-com era, before the mass adoption of the internet. I don't think any of us could have really anticipated the impact that it's had on our lives. And online banking has only been the tip of the iceberg, really. But it's not just the content that's changed, it's the way we access that content online. It's not just the what, it's the how, it's the when. If we looked around this room, I imagine most people are accessing the internet on lots of different devices, smartphones, tablets. Our ability to consume content is completely different. Our world is always on. I have a 10-year-old son. He has no concept of the notion of terrestrial television broadcasting channels, television programs at a certain time. For him, his world is connected. He watches his programs on his iPad anytime he wants, 24/7. We've seen that world change when 2 billion people have got onto the internet. We've seen the rise of social media, the creation of a digitized entertainment industry, and the retail industry completely changed. But today, I want you to think about all of that interconnectivity and what it means in the industrial world. Instead of you and I being connected, what would it mean if machines could be connected? Let's think about an example of a farm of wind turbines. Imagine these turbines here, and if they were able to talk to each other and understand each other's position. They could talk about the prevailing wind conditions. They could talk about their own individual performance. And they could work together to optimize their power generation output. The same concept could be applied on an aircraft engine. Imagine if an aircraft engine on the wing of an airplane could tweet back to the ground to let the engineers know on the ground when it needed to be serviced. That type of interconnectivity is something we've never seen before. Imagine what that would mean to our ability to improve performance, to reduce unplanned downtime, and improve the safety and the reliability. We call this world the industrial internet, and it's a massive revolution. And it was really predicated on three things, the three things we have here. The advent of big data, smart, more connected machines, and real-time analytics. And it's the convergence of all three of these that are really driving such a monumental change. Jeff mentioned earlier about the example of the aircraft engine here. Traditionally, an aircraft engine would supply us with 3 pieces of data. Some data on its takeoff, some on its cruise, and some on the descent. Now we're able to capture 5,000 data points from that jet engine in flight every second. And that equates to about 1 terabyte of data every day. That's more data than we've ever had before. Secondly, we have smart, connected machines. An example here is of a locomotive. This locomotive we can cover in sensors, and it can collect data, feeding back to a data center possibly thousands of miles away, and indicate the performance of that locomotive and allow us to analyze and control its behavior. And the third space is that real-time analytics and decision-making. With those smart connected machines producing an enormous amount of big data, real-time analytics allow us to put that together and derive insights and understanding of the data in real time. Let's imagine what that means. We've got the potential here to see trends and patterns in the data and see things that we've never been able to see before. It's almost as if we can predict the future. And in this case, we might be able to look at a piece of machinery and predict when it's going to break before it actually does break. That predictability can lead to lots of things. It can give us a machine which is more reliable, a machine which is safer, we can optimize fuel economy, and ultimately we can drive, as Jeff said earlier on, no unplanned downtime. That's an amazing value proposition. This whole area of asset optimization through the industrial internet is so large that Gartner positions this as a $300 billion market by the year 2020. Here in GE, we have $1 trillion worth of equipment out at our customer base. So for us, this convergence of smart data, of big data, smart connected machines, and real-time analytics makes a lot of sense to us. And we believe it makes sense to you as our customers in getting more out of the machines that you have. So how are we going to go about living in this industrial internet world? We've got 3 things underway in GE which I believe will make a fundamental difference to the way we deliver. The first is people and software. We're investing $1 billion around the world in our software business. The second is Predix, which I'll talk about in a moment, which is our underlying operating system for the industrial internet. And the third are our customers and the relationships we have with our customers. Firstly, on the people and the software. GE has always been in the software game. We have around 13,000 software engineers already in our business. And in the last few years, we've invested $1 billion in a software center in San Ramon in California. We've added another 1,000 software engineers who are dedicated to architecting solutions for the industrial internet. Today, that number makes us one of the top 20 software companies in the world. Predix is our operating system for the industrial internet. I want you to think of it like an operating system that on top we can sit applications, and we can build applications with our customers that will solve specific problems. It glues together the machines, the data, the algorithms, and the analysis, and allows us to form that safe, secure method so we can quickly produce applications. To date, we've produced around 40 applications this year, with a lot more in the pipeline. And thirdly, our customers. We have a very collaborative relationship with our customers, and we recognize that developing software for the industrial internet going forward isn't going to be the same traditional software methodology we've used in the past. No longer are we going to be writing specifications and having code developed a long way away. Software development now is much more agile, it's much more collaborative, and we need to work with our customers. We've built a very strong user experience team called UX, and that UX team works closely with the customers to understand how you would use these type of applications, to make sure that the applications we build are incredibly focused and tailored to the way that you work. For example, we recently redesigned a ship positioning piece of software that we had in GE for many years. And the UX team, the user experience team, went out and spent time with the mariners on ship out at sea. And after several days at sea, watching and observing the mariners, they were able to see exactly how they used that system. And they found that the current design of the software was completely inadequate for their needs. They were able to redesign it and have a much more successful product that's really suited to the way those mariners work. Now, we also recognize that we can't manage this industrial internet environment on our own. It's a team sport. So we formed a global industrial internet consortium with some of our partners, Cisco, Intel, IBM, AT&T, just to name a few, recognizing that there's a whole end-to-end ecosystem here that we need to manage. Locally, we're working with other partners such as the CSIRO and other agencies to make sure we come up with solutions which are really tailored to Australia. And we've got some great examples which I can share with you of where we're going in that area as well. The first is an example from our oil and gas business, which is a relatively new project that we've got underway. We're working with one of our customers here to look the whole end-to-end process in their business. We're looking at potentially building a Predix platform which will allow them to collect data from both their onshore and offshore operations, bring that data into a central Predix platform and do real-time analytics, which will help them improve their safety, their quality, and their unplanned downtime. They see this potential project as delivering $1 billion worth of benefits in 5 years. Now, typically, an offshore and onshore operation like that would equate to something like 7 to 10% of their OPEX. So a massive project for one of our customers. Now, this is very early days, and we're working with our team in San Ramon, but we're very hopeful about where that project's going to go. The second example is in the rail space. Here in Australia, we operate the Evo locomotives. And on that locomotive, there are 250 sensors that generate something like 9 million data points an hour. Now, at the moment, we're using that data to help the operator reduce their service intervals, and we've seen them be able to get a 50% reduction in repeat failures. But we've got more data than we've ever had before. So going forward, we see this foundation data as the platform for us to be able to do a lot more. The next stages of this could be potentially looking at fuel efficiency, and beyond that, this could be a foundation for more autonomous control in the locomotive. So overwhelmingly, the industrial internet has some massive benefits. In some respects, we see it as being the same type of monumental change that the consumer internet has had on every one of our lives. Here in Australia, if we want to be successful in this future technology world, we need to be successful in our knowledge economy. We're going to need to invest more in STEM, as we've talked about this morning. And we're going to need to be cognizant that the environment will change. Traditional jobs may disappear, and new jobs will take their place. And we need to recognize that there's going to be a lot of productivity and commercialization benefits of the industrial internet. We're at the beginning of a new journey. It feels very similar to the first time we saw the internet 20 years ago. The possibilities are boundless, but we're incredibly excited about being here today and being with you today on that journey for the next 20 years. Thank you.